This video covers chapter 8.4 of the book Spring Boot Quick Start. In this chapter, we will see how to use Finder methods to retrieve entities from a database. Now, Finder methods are methods that can be added to the repository interface. By default, repository interface only has one method, findById, that can be used to select records from the database. This method returns a single record based on the primary key. But you can add additional JPA Finder methods that can return records based on combination of other properties in the entity. You can add such methods based on the rules for creating Finder methods, which are described a little bit further in this chapter. And then JPA will create select query by parsing the method name. So these rules define how you can name these methods, and the name is actually being parsed to create a select statement. This means that method name defines which properties are used and how they are logically connected to query database. JPA Finder methods are only used to query database by generating select statement. This means that they can't be used to create insert, update, or delete statements. To insert or update a record, you should use a standard repository method like method save. So here is an example of 3 Finder methods that have been added to our interface, repository interface. Here, this method finds a record or entity by its name, and then the name that we are looking for can be then given as a parameter. And since multiple entities might have the same name, the method can return the list of entities, in this case the list of persons. This is another way to create the same method as above by using this prefix, find person, instead of just find. And this Finder method shows how we can combine multiple properties and how to logically connect them. So this Finder method will find persons with this name and this age, where name and age can be given as a input parameters into this Finder method. Now in this table we have a list of keywords that can be used to create a name for the Finder method, together with examples of how the final name might look like. So we have already covered this method, find by name, which will create a SQL statement with following where clause. It will use the name property from the entity and then look for entities by using this SQL where clause in the SQL statement. Or we can have find name ignore case or not, or using not, which creates this SQL statement. So you can go through this table to get a feeling of which keywords can be used and in what way they can be combined, and which SQL statements will then be generated by parsing the Finder method. We will now take a closer look at the rules that need to be followed when specifying a finder method name by using these keywords listed in this table. So the name must start with one of the following prefixes: find, read, query, get, or count. Which means it can start with count, then it can be followed by any string, but then it must end with by. So here is an example where it starts with find. There is no additional string between find and by, and then it ends with by. And after that, we can use the keywords described in the below table. Or it can start with find, then we can insert any string between find and by, and then ends with by. So this is our prefix. After that, we are using our properties and combine them with the keywords described in this table. So these first few prefixes are aliases. They more or less behave exactly the same, but depending on the implementation, they might behave differently if no records are returned. And this last one, count by, returns a number of records matching specified criteria instead of returning the actual records as these others do. To limit the number of returned records, we can add keywords first or top. They behave the same, again these are aliases, before the by word, followed by the optional number specifying maximum number of records that we want to be returned. So here are some examples. Find top by, without specifying the number, and find first by without specifying the number, or with specifying the number, find top 10 by, or find first 10 by. So these two are the same, and these two are the same. They will return the top 10 records. Distinct keyword returns unique combinations of specified columns among returned records. If we want to select unique results, we have to use distinct keyword before the by keyword. For example, find distinct age, birthday, by. So it will only return records that have distinct combination of these two properties. Now, search criteria is defined after by word by combining keywords with entity property. So these are the keywords here, and in our cases, this name is entity property, birthday is entity property, age is entity property, active is entity property. So we combine these keywords shown in red with properties from the entity that you might have defined inside the entity. Number of method parameters must be the same as the number of search conditions inside search criteria. Method parameters must be given in the same order as the search conditions. So we are now talking about this. So if we have a keyword like which accepts one parameter, then our input method needs to have one parameter. Or if we have a keyword between which accepts two parameters, then our finder method needs to have two input parameters to work with. Or here we have two properties, that is two parameters, and for each we need to create an input parameter into the method in the same order in which they are defined in the name of the finder method. Names of method parameters are irrelevant since they are mapped to the properties based on their position. So this is our finder method name, which is using two properties to generate SQL statement, and these properties will be loaded by these input parameters in the order in which these parameters are given. Therefore, the names of the input parameters are irrelevant. So first input parameter will be used to get value for the first property, and second input parameter will be used its value to load the value for the second property. Again, in this table, here is such the same example here. First property or parameter, the second property, and so this first parameter loads the first property and the second parameter loads the second property. And we will end this chapter by shortly explaining what is a projection. Projection means to only retrieve some entity properties within the retrieved records. So closed projections use interface methods which match the names of entity properties, and open projections use interface methods with custom names that return computed values. Open projections retrieve all entity properties since they doesn't know in advance which properties will be used. So if this is our person entity, so this means that when we create a finder method, that method can return what is known as a projection. So here, previously, from our finder method, we were either using a single entity, in this case person, or multiple entities, in this case a list of person. Now if finder method returns a person entity, it will return person entity with all the properties that are defined by this entity and which are therefore stored in a database. So if we have a person entity with 20 properties, they will be represented with 20 columns in the database, and then this finder method will return person entity with 20 properties. This can be time consuming for the database if we are only interested in retrieving maybe just few properties like name and age. So in order to return only subset of entity properties and not all of them, we use projections. So projection is used to only return some of the properties from the database that we are interested in. We do this by specifying projection, in this case a closed projection, as an interface, and then specifying setter methods that can be used to only retrieve getter methods that are used to only retrieve specified properties that we are interested in. So the enclosed projections use interface methods which match the names of the entity properties. So we have entity properties name and age, and therefore this is why we use these getter methods. So once we define this closed projection interface that specifies that we are only interested in name and age properties, we can use this interface as a return value of our finder method. And then our finder method, instead of returning a person entity with all of its properties, it will create an instance of a class that implements this interface, which is done by Spramwork for us, and that will only have these two getter methods and therefore only these two getter properties. And if we wanted to have open projections, then interface method can have custom names. So this doesn't have to be get name, it can be get whatever. And then we would be able to specify the body of such a method to actually return certain value that is computed from the properties of the entity. But in that case, all entity properties are returned. It's just that these additional getter methods will then help us to get the values that are result of computation between all these properties. But in this case, to make things simple, we just have entity. We have close projection interface, which says that we are only interested in these two properties, and then we use this close projection as a return value type of our finder method, so that when the finder method finds the person entity we are interested in, instead of actually returning a person entity, we would be able to work with a instance of this interface that only has these two properties or getters that we are interested in.